Guys, and welcome. On today's video, I'd like us to discuss inverses of matrix. Okay, so let's suppose you're given a matrix A with the entries A, B, C, D, just like that. Okay, and you are asked to find the inverse of matrix A. So the inverse of matrix A, it has a formula 1 all over the determinant of A multiplied by, you exchange A and D, so that will be D and A there. Then you put negative on C and B, so minus C minus B, like that. Okay, so for a 2 by 2 matrix, that is how you're going to find the inverse using this formula. So let's look at an example. Let's suppose you have matrix B with the entries 2 1 minus 2 4, just like that, and they want you to find the inverse. Okay, the first thing that we want to do, according to the formula, you see that we're going to need the determinant. Okay, so let's find the determinant of matrix B. The determinant of matrix B will be 2 by 4, that is 8, minus 2 by 1, that is 2, minus 2, like that. So you see that is going to be 10. Okay, so that implies B inverse is going to be 1 all over 10. It's 1 over the determinant. The determinant, we got it as 10. Then it says we should switch D and A. That means 4 and 2 have to switch. So there becomes a 4. Then a 2 goes there. Okay. Then we introduce negatives on this one and that entry there. So here we're going to have a 2 again. Then here have minus 1, like that. Okay. So when we multiply inside by 1 over 10, 4 by 1 over 10, that is basically 2 over 5. Then by minus 1, that is minus 1 over 10, like that. Okay, then 1 over 10 by 2, that is 1 over 5. Then 1 over 10 by 2 again, it's 1 over 5. So that is the inverse of matrix B. Okay, so yeah, you can see that finding an inverse for a 2 by 2 is pretty easy and it is pretty simple. Let's look at another example. Let's suppose you are given a matrix D, where the matrix D has the following entries: 7, minus 1, 2, 3, just like that. Okay, so we want the inverse, so we are going to look for the determinant first. Despite that, it will give us minus 7, then minus 6. 2 by 3 is 6. Since we are looking for a determinant, we got to subtract there. Then that will give us minus 30. Okay, then that implies not B but D inverse is going to be 1 all over the determinant is minus 13 multiplied by, we're going to switch 7 and 1, so we're going to have minus 1 there, then 7 there, then introduce negative on 2 and negative on 3, just like that. Then distribute 1 all over minus 13. So 1 all over minus 13 by 1, that will be 1 all over 13. Okay, there's a negative there, so they're going to cancel out. Then here we're going to have 3 over 13. Then there we're going to have 2 all over 13. And here we're going to have minus 7 all over 13, just like that. So that is the inverse of matrix D. So doing a 2 by 2, it is pretty simple. You all can see for yourself and are able to follow. So now I would like us to find an inverse of a 3 by 3 matrix using what they call cofactor. Let's use cofactor method. Okay, so we know we can find it by using the identity, but I'd like us to consider using cofactor method. Okay, so in order for us to find inverse of a 3 by 3 using cofactor, there are several things that we have to keep in mind. Is that obviously the first thing is that the determinant must not be 0. Yes, and we must also pay attention to the signs. So since it's a 3 by 3, the signs are going to be plus, minus, plus, minus, plus, minus, plus, minus, plus, just like that. And we have to know that the transpose of comatrix of a cofactor matrix is equal to what we called an adjoint matrix. okay, is equal to an adjoint matrix. So the formula to find an inverse of a 3 by 3 by using cofactor method is given by 1 all over the determinant of matrix A multiplied by the adjoint of matrix A. So how we are going to find the adjoint is that we are going to use cofactor, then the transpose of cofactor is going to give us an adjoint matrix. Okay, so let's look at an example. Let's suppose you are given matrix A with the entries 7 2 1 0 3 minus 1 minus 3 4 minus 2, like that, and we want to find the inverse of this matrix. Okay, so the first thing that we are going to do is to find the cofactor of each entry, and when you do that, do not multiply by the entry itself. Okay, so we want to find the cofactor matrix. So I'll just call that cofactor matrix, let's call it B, okay, for simplicity reasons. So let's call it B. So we are here on 7, so we're going to cancel the respective column and row, so we're left with 3 by minus 2, that is going to be minus 6. Then 4 by minus 1, that is going to be minus 4, but since we are subtracting, then it's supposed to be plus 4. So the first entry here we get minus 2, so that implies the first entry here is going to be minus 2. Okay, because on the sign there is positive, so it's not gonna affect this negative 2. We're gonna take it as it is. Okay, for the next one, you have to pay attention to the sign. It is going to be negative. It's gonna affect, it's a negative, it's gonna affect whatever we find for the cofactor of this entry 2. Okay, so the entry here, we cancel this and that, so it's 0 by minus 2, that goes away. Then minus 3 by minus 1, that is going to be 0 minus 3, so it's basically equal to minus 3. So this minus 3 is going to get affected by that sign, so we end up going to have positive 3 instead. Okay, so for the 1, we cancel this and that, so it's 0 and minus 9, but there's a sign there, so it's going to be plus 9, so that gives us 9. Okay, so it gives us 9, and the sign here is positive. Okay, for this entry, the sign is positive, so we're gonna keep it as it is. It's gonna be 9. Okay, then we go to this one, we cancel the respective row and column, so it's 2 by minus 2, that is minus 4, then minus 4 by 1 minus 4 minus 4, that is minus 8. So minus 8, paying attention to that sign, that is going to then become positive 8. Okay, then for the 3, we cancel this and that, cancel this and this one, so it's 7 by minus 2, that is going to be minus 14. Then minus 3 by 1, so it's basically minus 14 plus 3, so that will give us 11. Okay, so here we're gonna have 11. Then for minus 1, we're gonna have to pay attention to that sign. Okay, so you notice that I do not multiply this cofactors with the entries. Okay, I just do like I'm finding their determinant, but I do not multiply with the entries. So don't make that mistake of multiplying with the entries. Yeah, let's carry on. We are on minus 1, we cancel this one and the middle row, so what is remaining is 7 by 4, that is 28. Then minus 3 by 2, that is going to be minus 6. Then since there is a minus, then it's gonna be 28 plus 6, that will give us 34. Okay, then on this entry here, on this entry there, okay, it's gonna, yeah, it's 34. Then we have to pay attention to the sign. Yeah, sorry about that. So here we're gonna have to have a minus due to that sign. So make sure you do not forget these signs, because if you don't put the corresponding sign accordingly, you're gonna get a wrong inverse. Okay, yeah, then it implies for minus 3, we're gonna cancel this and that, so it's minus 2 minus 3, that is gonna be minus 5. Then for this one, 4, we cancel this and that. Then we're gonna have minus 7. Okay, but however, we have to pay attention to that sign. So minus 7 by negative, that is just going to be positive 7, just like that. Okay, then for the last entry, what we are going to have for this one, we cancel this and that. Then it's 7 by 3, that is 21. Yeah, so it's just going to be 21. The sign is positive, it doesn't have much effect. Okay, so we have found the cofactor matrix. Then on this point, I said that the transpose of cofactor matrix is the adjoint matrix. Remember, we're going to need an adjoint matrix, since you see according to the formula it says A inverse is equals to 1 all over the determinant times the adjoint matrix. Okay, so we need the adjoint matrix now. So we see that the adjoint of A is going to be the transpose of matrix B, just like that. Okay, so when we transpose this matrix, what do we get? We get minus 2, 3, 9, 8, 11, minus 34, minus 5, 7, 21, just like that. Okay, so we have done the adjoint, we have got the adjoint, we have got this. So what is left off is to find the determinant. Okay, so the determinant of this matrix, what is it going to be? I'm going to use this first column. Okay, remember, you can use any column or any row to find the determinant. So I'm gonna use this first column. I'm taking advantage of this 0, so it's gonna annihilate one of the minor matrix there. Okay, so the determinant of matrix A is going to be 7 multiplied by minus 6 plus 4. Okay, then minus, the minus is coming from here. This was for 7, this positive is for 7, then this minus is for 0, then this positive is for minus 3 there. Okay, so I'm having minus 0 by what? So we cancel this and that, so it's gonna be minus 4 minus 4, so it's minus 8. Okay, then minus 3 into, we are here, on minus 3 we cancel this and that, then minus 2 minus 3, just like that. So this determinant simplifies to 6 plus 4, that is minus 2 by 7, that is minus 14. Then this side we get minus 5 by minus 3, that is positive 15. So the determinant is basically equal to 1. So A inverse is therefore equal to 1 all over, according to the formula, it says 1 all over the determinant, and we got the determinant to be 1 there, so it's 1 all over 1 multiplied by the adjoint. The adjoint matrix is this one, so we're gonna have minus 2, 8, minus 5, 3, 11, 7, 9, minus 34, 21. So that is just basically equal to the entries they do not change, so it's just minus 2, 8, minus 5, 3, 11, 7, 9, minus 34, 21, just like that. So this is how you find the inverse using cofactor method. Okay, yeah, thank you very much for watching the video. Please subscribe and hit that like so you are notified next time I drop. Thank you very much.